Hello and welcome back to Mikey's Flightdeck. Today I will show you how you can build your own pneumatic section for your Boeing 737 overhead panel.
First of all, you need to install 5 big on-off switches. In the middle section you need 3 on-off-on switches. And 2 black push buttons. The 2 bezel parts are cut from clear acrylic with the outside ring painted. Then I install the dual needle gauge that I showed you in a previous video.
I have already demonstrated one technique I've used to create these black and white colored panels. These were made on my CNC router and came out really nice, not perfect, but good enough to work with this. Now, after I have produced my first panel with the help of my new laser cutter, which increased the cutout and engraving of every panel really much, I thought if it could also help me to produce these 2 colored panels better than I'm doing it now. My actual technique isn't not too bad, but the black wax I'm using to color the engraved areas is not made to fill such big areas. It is made to fill only small and narrow engravings, only some letters or something like this, but not these more than a millimeter wide lines, for example on this pneumatic panel here. There we come out with some really thin colored areas where light comes through and they don't look even made. There are some areas with a little bit more backlighting, some with a little bit less, and I think we can make this looking more professional. And though I thought about a method which is based on making some inlays with this laser. But before I explain the following steps, we have to take a look to how a laser is cutting and how the lens affects the kind of cut it is doing. So when you want to make an insert for a cutout you have made with a laser, then most people would think, when we look from the top now, here is our piece where we want to make a cutout, maybe here, like this, and from another piece we will cut out a piece with the same dimension, take it and put it into here, and it will fit. This can work. This is the method I'm using when I make my bezels for the gauges, but when you want to come out with a perfectly tight fit here, then this couldn't be the method. Because when we will look from the side here we have the cutout. You would think then your piece would now come into here and will sit flush. But this is not how it is working. When we cut out something with a laser, then the edges would look like this. Here, there, and like this. So you can see there is an angle in this cut. It's not that big, but I think you can get the idea behind this. And the piece we would set into would look like this here. And you can see this wouldn't fit into each other. So why do we come out with such angles here? So we have to know how a laser works first. The laser beam comes down here to the lens. And this lens will guide the beam to something like this here. And this is here what you call the point of focus of your laser. This is a distance here from the lens where you want to set the surface when you cut most of the times. And now when we place our acrylic piece here and the laser cuts, you can see what comes out here. There it is, the angle that comes out when we cut out any acrylic piece here. You can reduce this angle when you change the lenses. There are other lenses that have a longer focal distance, and then it would come out with something like this here. And you can see the angle when we cut the same thickness of material would come out smaller here. But lenses with such a long focal distance wouldn't be good for engraving. So you have to make a compromise there. But this should hold us back from following our plan here. We just have to think how we can make our cutouts and engravings. And let's start with the small black engraved pieces. When we cut out these pieces, we'll come out with a piece like this here. So like this. And here on the top, there is our engraving. And now we have to change something in the way we cut out the hose for these pieces in our main acrylic board so that they fit to these angles here. And to achieve this, we can turn this around. And when we turn this around and the laser comes from the other side for cutting, then we come out with cutouts that look like this. And you can see our piece would fit into here perfectly. But we can't use the same cutting path for the hose and these inlays here. For example, when this is a cutting path for our hole, then our inlay should be a little bit bigger. So I said a little bit, but to see it better, I draw a little bit more. So this will be our hole, and this, in an extreme way, will be our inlay piece. And now we have to find out how much this piece has to be bigger than the cutout. So now that we know we have to produce two different parts, a piece with the hose and the cutouts in it, and one piece that is the inlay, which is cut from the other direction. And we can have a look here what I have thought about. This is the white painted top panel part, and I will have to cut out here the hose for the inlays. And I think this can be the mirrored cutout. So I will turn it around and put it into my laser cutter and make all the cutouts. I'm doing the cutouts after the white painting because I think the two parts have to fit absolutely perfectly into each other. And when I cut the hose first and spray paint over it, then paint will also cover the insides of the cutouts. And then the two parts couldn't fit anymore to each other. And then I'm taking a white acrylic, which I have painted black on one side. Don't look at these cutouts here, it's just a scrap piece, which I have used here for this purpose. And I will lay down into the laser cutter, engrave all the needed texts and lines first, and then cut out the parts. And so I have a so-called left and right piece. And when I then take these cutouts from the black acrylic, they should fit in perfectly into the cutouts of the white panel here. But to achieve a really tight fit here, the cutouts of the black acrylic have to be a little bit bigger than the cutout in the white panel. And this can be different from every machine you are doing this with. So I have to test now which value of offset could be the best to achieve a really flush fit with my laser here. And now after several tries, I think now I have the correct offset. And this is a really tight fit here. And you can see no gap here, and it feels flush when I push this in here. And this is an offset of 0.14 millimeters. So this is the value I have to cut out the things bigger so that there will be no gap later.
To align the painted panel on the bed, I draw the outside of the panel onto some pieces of MDF.
So here we are now with the finished result. You can see I already have made a engraving mistake here because I have forgotten to set the focus correct, but that's the advantage of working with a piece of scrap acrylic here. There is a little bit of white powder left over here on the surface. I have to change a little bit with my air settings here. This is something I want to do in the future, but I think this is looking good. All engraving came out clear. So I will clean this now a little bit, and then I can break them out. You can see they come out already here. And then we will see if it fits into the panel. And now comes the fun part of the project, a small puzzle game. I turn the white sheet around and then put in all the black parts from the back side and push them down until everything is flush here on the back side. I do this on a piece of paper to save the lacquer until it's not covered with some clear varnish.
The layers are fixed together with some screws and 15mm hex standoffs. Then some orange and blue annunciators are needed.
Damn, I hate those cheap switches. I'm preparing these switch caps here from these aluminum shafts here, and the aluminum tube fits over these switches here, but it doesn't fit over these here, it can't get over. The diameter of these three switches here of the shaft is a little bit bigger than at the other ones here. They come from the same package, but they are a little bit different. So I have to do a small operation and sand a little bit away of the metal here from the switch.
Now finally everything is connected, every cable is soldered to the breaker board of the Arduino and to the switches and so on. I have connected a 5-volt power supply for running the two servo motors. I have started prepared in the background and the MobiFlight connector already running here. And when you look at the live view, you can already see some LEDs lighted up. So I think all the configuration aren't so wrong. What have I done? Let's go to MobiFlight first. I know you have seen these settings in my previous videos, and again, I'm not going into detail again. You can watch previous videos of me where I go into the configuration of Prosim and MobiFlight in detail. Here under Extras and Settings, under the MobiFlight modules, you can see my Arduino F, where I have assigned some new devices, LEDs, buttons, and down here F56 and 57, the two servo motors. And I have assigned here the inputs and outputs. They are active so that the signals can come through here. The settings in Prosim you can do here under config and configuration and combined config. And you will find all the values you need here in the Pneumatic region. And there we have the switches. For example, you can see here the bleed on and off, 1 for the left, 2 for the right side. And all the other values I have assigned all the offsets. By the way, you can find all the offsets I have used in my connection sheet that I have uploaded to my website. The indicators are here in the indicator category, also with all the offsets here. And on the top here you have the two colored LEDs, the blue ones with a bright state, and these bright states that I simulate with a white LED inside you can find here under gates, and there are the render full open left and right bright state where I have assigned the offsets. And at least the gauges. I have shown you this already in the video of my dual needle gauge, but for completing this here, you will find there the pressure left and pressure right. And here we have already set the values in the dual needle gauge value so that the two needles will find the correct positions. And now it's time for some testing. Some LEDs are already lighted up. Let's test the other ones. And this we can do here in Prosim displays. Here I have arranged the display so that I can see the pneumatic panel. And we can click onto the annunciators. Dual bleed is on. Let's check down here. Offset descent, alternatives, and manual are lighted up. There's 6 other ones. Pack trip, wing body, and bleed trip off. And for the right side, pack, wing body, bleed trip off. These are working. Now to the switches. Here we have the on and off, APU bleed and off. Off is working. Let's say it's on off here. Isolation value is on open. There, on open. And close. It's working. And recirc fan. So now it's initialized. Auto, off. And this one too, let's initialize it. It's off, auto, and off again. So the switches here are working. Let's check now the two push buttons. And for this, we can change again to Prosim, here to the Pneumatic category. And there we can see, for example, what we are looking for, the overhead test button. And when we push it, you can see it changes the value here to on, and the trip reset. There's the trip reset, it's off, and push it, and it changes its value to on. So every switch is working. Now let's test the gauge. And for this, I have started the APU already. And I can switch on the APU bleed here and the 2 packs on auto. And here you can see the left needle is already going up. And to bring the right needle also up, we can use a little tool here from Prosim. And for this, we open our browser and go to localhost 8080. And there you enter the instructor station. I think I've shown this in a previous video. And I will switch the ground pneumatic connection to on. And then we will see the needle going up. I move the instructor station to the other monitor and press now it on connected. And here you can see the right needle moving up. And so I think we have shown that everything is working here now.
The new panel section is finished, everything is working, and especially the new inlay technique for the backlighting comes out really great. I think I will replace the other panels with this new method here when there is a little bit more time. Yes, time, but there is no time. I think I have to go on building the next sections for the overhead panel. And if you want to build your own overhead at home, then you can find everything you need to build these panels in the member section of my website. You will find DXF files for downloading and to use it in your CNC or laser machine to cut out these panels, and all the other files I have created for building all the other things you have seen in my previous videos. And for not missing these upcoming steps in my cockpit project, subscribe to my channel to stay informed about any upcoming new video from me. So I hope we'll see you soon back on the flight deck.